This question is definitely annoying. You can just tell by looking at it there's a lot going on, and there's a temptation, I think, in this question to kind of deal with all of the things that are going on, and we really need to keep it as simple as possible. So our big strategy here is going to be get back to basics. We can see that they are trying to get us to think about lines, okay? Because both of the equations here kind of look like lines. Now, there's inequalities involved, but let's start out with a more simple thing, which is just thinking of these as lines and then dealing with the inequality piece second, okay? So the first thing I would do is just recognize, all right, these are in y equals mx plus b form, so I can try to graph them, okay? And so let's see, well, this first one here, y, let's say, equals 2x plus 1, okay? Well, if I were graphing that, I would have a y-intercept of 1 and a slope of 2. Now, here's a case where we want to keep it just a little simpler. There's a temptation sometimes to make very complicated, precise graphs. Okay, you see a graph opportunity and you want to make all the little scale marks the same and everything is to be perfect, and I don't think that that's a good idea. Generally speaking on the SAT, if we're meant to graph something precisely, they're going to give us graphs to actually plot whatever we need. If they give us something like this, then we can pretty much just do a sketch and rely on the sketch. So if you catch yourself doing one of those really precise graphs, you're probably doing it wrong or inefficiently. So let's just say for now that a plus 1 y-intercept is somewhere here, and then a slope of 2 is going to be kind of steep, so I'm going to do something like this. Okay. So that's my line, my first line, and then my second line, 1 half x minus 1, same deal. Let's ignore the inequality for a second. Let's just focus on the plotting. And it's going to have a negative 1 y-intercept, and then a slope of 1 half. That's still a positive slope, but it's a little bit shallow. So I might do something like this. Okay. Now we can start to deal with the inequality piece. Now, the other thing, too, is that they want to know which has no solutions. And we know that if we didn't have inequalities, the solution is where the two lines intersect. So we can see that that's happening right here at the point of intersection, and that's in quadrant 3. So that's not going to be our answer because there's definitely a solution right there. Now, in graphing the second line, I ignored a little thing, and it doesn't really matter, but some people might not like that I ignored it. Basically, there's a difference when we graph inequalities between graphing a, in the green case, a greater than or equal to versus in the purple case, a regular old greater than sign, right? So what we are supposed to do is do one of these kind of like dashed lines here and show in the purple one that the line itself is not included in the inequality. It really is not going to matter here. This is not about that. This is about whole quadrants. So whether or not we include the line is really not going to make a difference in our answer. So we don't need that. But for the sake of completion, there it is. Or maybe there will be a question on the test where it is necessary, and now you know. But the piece that most people mess up with inequalities is understanding how to shade the graph. We all learn this in school at some point, that when we have inequalities, we graph the line, and then we shade in some direction based on the inequality symbol. And the way I learned it was actually really confusing. I learned kind of that you just like pick a point, see if it works in the equation, and then if it does, you shade in that direction, and if it doesn't, you shade in the opposite direction. But I don't think that's particularly helpful, and when we have things in y equals mx plus b form, then it's actually really easy to tell which direction we need to shade, okay? And this is why getting back to basics, getting back to y equals mx plus b form is so helpful. So what you really want to do is think about, okay, if this means that y is greater than 2x plus 1, then it means that the inequality is saying we want to include y values that are greater than the y value that would be just normally part of the line. And y is just an up or down thing. So if we want y's that are greater than the line, we want to shade above the line. And so I'm going to use the highlighter to do this. But basically, we want shading that kind of just goes like this. So it's everything above the green line. And then for the purple, it's going to be the same thing, right? Because it's also greater than. So it's going to be everything above the purple line. And it's getting a little messy. This was going to happen. This was inevitable. This is a complicated question. But I'll use one more color to show you where it counts, okay? Because we've got a lot of things going on, but not all of it matters. Because they want to know where are the solutions to the system. So when we have a regular single line inequality, the solution would just be whatever is shaded. But when we have two inequalities, we want the solution to the system. Now, normally, if we want the solution to a system of regular old equations, we want the point of intersection. We want to see where the two lines cross each other. The same thing is true here. We want to know where these inequalities cross each other. So we want to see where the two shaded regions overlap. So I don't care where the pink is. I don't care where the green is. I only care where the green and the pink meet each other. Okay? So that's going to happen. I hope this is neat. That's going to happen right here. Okay? So it's above the green and it's above the pink or the purple. So that shows us that there are definitely solutions in quadrant 2, right? We can see it just based on most of the yellow is in quadrant 2. We can also see that there's still some yellow in quadrant 3 because it's kind of where we saw the regular old point of intersection before, and it continues to go up beyond that. The weird one is quadrant 4, okay? That's going to be the answer because there are not solutions in all 4 quadrants, okay? There's this weird sliver. I'm going to try to highlight it again. Let's use this color. There's this weird sliver in quadrant 4, right here, that is shaded pink, okay? So if all we had was the purple-pink line, then we'd be good. That would be a solution, and yes, there would be solutions in all 4 quadrants. But because we have a system, and there's only pink there, no green, that does not count as a solution. It has to be where they overlap. And the green line never even passes through quadrant 4, so there's never going to be any shading above that line that is in that quadrant. So it's a weird circumstance. And the odds of it coming up again are pretty slim, so if you're confused, I wouldn't really worry about it too much. But I do think that in doing this very complicated question that involved a lot of different stuff, we were able to see more clearly a lot of little rules that might appear in an easier question individually. So graphing lines, you will absolutely need to do that on your test. Inequalities is a little different. I find that most of the time that we have inequalities on the SAT, we have points, so we have actual values from that set that we can plug into equations and test. And that's definitely better. Because I don't love this whole sketch thing that I had to do, but it's certainly better than trying to meticulously graph the two lines in the system. We didn't need to do that. We can see what's going on without it. But, it's still a time-consuming question with a lot of room for error. I would say the number one thing to take away from this, actually, as far as inequalities goes, is that when we are in y equals mx plus b form, we can think about shading as a vertical direction, right? We either shade above the line when y is greater than the line, or below it when y is less than. And that helps us understand what we're shading much more easily, I think, than the way I learned it. Hopefully this helped. Whenever things get weird, though, good advice. Get back to basics, and hopefully it'll get less weird.